Hi, um, today we're going to explore how to simplify expressions using properties of exponents. Um, I don't know, but to me, to work with exponents is like to do anything you want by following the same laws. Like the attraction law or like the compensation law. You can do anything in your life, but these laws following the course of your life. So this is how we work in math with exponents. Doesn't matter how you apply or how you simplify expressions using exponents, but you should always follow the properties of exponents. If you follow the properties of exponents, you will always have the same answer and you will always have the same results. As compensation law or karma law that establish that if you do good things will happen to you. So you just have to understand the properties, understand the rules to know how to simplify expressions. So let me show you the properties of exponents. You know, um, Properties of exponents are very easy to understand, but is not part of this video. For example, same base and an exponent, you have to add the exponent. Same base, but in a division, you have to subtract exponents. Negative exponent is the same as 1 divided the base to the exponent positive. The zeroth exponent is 1. The power to a power is the multiplication of powers. Different base but the same exponent could be uh, written as both bases apart with the same exponent, and the same with division. So I'm going to show you an example how to simplify it applying the properties, but remember, you can simplify using other ways but following the properties. Okay, following the properties. For example, what do I do first usually when I have a parenthesis, a negative exponent, and I have a division here? I usually simplify the things inside the division and then I use power to a power. Okay, so let me simplify first. Simplifying the term inside the parenthesis. So how I'm going to simplify it? So look at, we have same base in x, but different exponent, 2 and negative 3. So we have to subtract it using this property. So we're going to subtract it. 2, we can erase this x here. We don't need it anymore. We can raise 2 minus negative 3. And if you're not so good in math or you're learning this, I prefer that you do this. Write this before simplifying. In this way, you're not going to have problems with signs. For example, here will be 2 minus 3, that is positive 3. So it's x to the 5th power. Let's see, 7 and y to the negative 2. So as this is negative and usually answers should be written without negative exponents, I'm going to move y in numerator as denominator. So I'm going to subtract negative 2, 7 minus negative 2. So this is 7 plus 2, that is 9. And here we have z to the 9th power divided z to the negative 9th power. So what you can do, you can move the negative exponent and move it to numerator. Okay, so minus negative 9. So negative 9 minus negative 9 is 9 plus 9, 18. 18. Okay? So I'm just following the rule. I just follow the rule number 2. Following rule 2. Okay? If you're a beginner, I usually recommend you to apply step by step. I mean, first one property, the property that you feel you need to apply, and then apply the other property. So I've just followed rule number 2 in this process. Now I'm going to apply another property. Apply rule or property. Now I'm going to apply the property of negative exponent, that is denominator. Rule 3. Okay, so this is negative exponent. This is a negative exponent. I'm going to convert it into a positive exponent. And what it says here, that if I have a numerator, I have to pass it as denominator. So you have a denominator, I have to move it to numerator. Very good. So if I change this to as positive now, it means that numerator now is no more numerator but denominator, and denominator will be now numerator. Okay? Now I'm gonna show you the step-by-step process. Sometimes some books didn't apply it, but as I'm explaining to you how to apply the properties of exponents, I'm gonna use it step by step. So I have a parenthesis and a power outside the parenthesis. So the property that I have to apply is number 6. So what if I apply rule number 6? Excuse me. Sometimes it happens. Okay, if I apply number 6, so this 4 will become 4 to the second power. This y to the 9th power will become y to the 9th power to the second power. And here I can apply power to a power, so it will be rule number 6 and rule number 5. So 9 times 2, 18. So essentially we have y to the 18th power. Now here I have 3. So it will be 3, negative 3 to the second power, x to the 5th power raised to the second power, raised to the second power, and z to the 18th power z to the 18th power raised to the second power. So let's simplify. 5 times 2, 10. So x to the 10th power. 18 times 2, 36. Z to the 36th power. Negative 3 to the second power is 9. And 4 to the second power, 16. So How do you test if you finish your answer? First, check that one base and one exponent has just one exponent. Check that you just have one base and one base of the same variable. Okay, and finally, check that numbers are simplified and no negative exponents. So I have no negative exponents, one y, one z, one x, numbers that are prime to each other, so we don't have some way to simplify it. So this is the answer. Okay? You can test the example using other methods. For example, some people prefer to start doing rule number 6 and rule number 5 and then simplify the same base. But the key is that you should have the same answer. So I'm telling you, if you do good things, you will have good results in your life. So in properties of exponents, if you apply the properties of exponents, you will have the same answer and you will have excellent simplifications. Thank you for listening. I hope that you enjoyed the video. Send me your comments. Send me anything that you need to study. Goodbye.